Alright, so I'm moving on with debugging of the factory manufactured boards. And on this board, which you've seen in the last video, there is no power beyond the 12-volt regulator. Like 12-volt regulator is not providing anywhere near the power that it's supposed to be providing. It's kind of outputting like 2 volts, something really rubbish. It should be outputting 12 volts, and it should be basically functioning properly. So what I've seen here so far was that the chip, the actual regulator, has been mounted a little bit rotated, and I tried to solder the pins of this chip, and I think all the pins are connected, but there is still no power. So I think that it could be, it could very well be that the ground pad underneath the chip is not connected. If you look at the PCB layout, this is the ground pad underneath this regulator, 54360. This is TPS54360, arranged to output 12 volts, and it has a ground pad underneath the chip. So I will try to desolder this chip completely and check whether there is enough solder on the ground pad, and then I'm going to put it back again. And then we'll see if the regulator works. So just to show you what it looks like right now, I'm going to power on the power supply, and I'm going to check the voltage on the output of the regulator. So I'm going to check the voltage on the, let's see, I'm going to check the voltage on the diode here. Let's see, maybe I'm not even going to be getting anything there, because I think, yeah, it's 1.8 volts on the diode, which is the location here on the schematic. So this is the junction that I'm measuring, and this is not supposed to be 1.8 volts. This is going to be a switching waveform that's supposed to actually be switching at the input voltage, and the output voltage here should be 12 volts, not 1.8 volts. Now I have my power supply at a much lower voltage, but it still shouldn't matter. Like even if I turn up the power supply to like beyond 12 volts, let's say 14 volts. Let's see what we get now. So now we get like 2.3 volts. So this is just probably something that that is getting onto this net from elsewhere. Like something that goes through some other chips, through some other component, and then just ends up on the output of this, on this 12-volt rail, on the output of this regulator. So I'm going to turn off the power supply, and I'm going to desolder this chip completely. And in order to do that, I will use a nozzle that will push the air just directly onto the chip, and not on the plastic connector that I have right beside the chip. I don't want to melt that connector. Alright. So desoldering this chip. And I'm going to use my other soldering iron set to 360 degrees. The hot air is set to 200, let's see, it's actually set to 300 right now, because I have to have it at a slightly higher temperature in order to melt this lead-free solder that the factory is using, but I have this one at 360 degrees, so I'm going to help with this soldering iron a little bit to melt, to heat up the chip a little bit more in order to melt the solder on the ground pad, and then I'll try to lift it off. I don't want to use too hot air, because that can actually damage the component. It doesn't usually happen, but it can actually damage the component if the component is exposed to higher temperatures for too long. Especially components that have a melting point, where you have the package made out of plastic which melts at above 260 degrees. That's really a pain to solder, and especially desolder when it's soldered like this. So this is basically soldered at the limit. So when they heat up the whole board, they can solder. They can just melt this lead-free solder and make it reflow, but they don't heat it up more than that. but when soldering with a hot air station, all of that, like it's very hard to heat up the board evenly all around the component because the heat escapes very quickly through the ground bias and through the ground plane itself. So the board kind of gets heated unevenly. And I can see definitely that there's very little solder on the ground pad, which could be the cause of this. Like there's flux on the ground pad. I can definitely see some flux there, but there is little solder. So I'm gonna put a little bit more solder on the ground pad, and then I will resolder this chip, and hopefully it will land perfectly and get soldered perfectly as well. And then hopefully it will work. Let's see. So we have. There's another little question here. Let's see. Where's pin 1? Pin 1 is over there. Okay. I'm just gonna double check because this is something I need to fix on this footprint because pin 1 is hard to see, and it's due to the fact that there is this line here on the silk screen. It's actually too close to the pin, so it's difficult to see. It doesn't actually sometimes. Sometimes you can't even see it. So I have to make sure that pin 1 is located there. So let's see. Yeah. Okay. So I'm gonna have the line towards. Yeah. Okay. I have an idea how to put it. So the line on the package is going to be towards the large inductor. Okay, and now it's time to heat this up again. Let's see. I'm going to heat it up again, and I'm going to make sure that it's sitting perfectly on the ground pad. So it looked like the chip was kind of soldered somehow, like it almost fell off or something. And it was sitting on the unmelted solder on the pads, which kind of made it sit a little bit higher than it should be, not fully touching the ground pad. But I don't know. Maybe it's something else. Maybe it's some other issue that's causing this chip not to function properly. But we'll see. Because it was not soldered properly, I have to resolder it and make sure that at least it's soldered properly before I can before I'll look into anything else. Okay, so I'm going to keep it slightly on the. I'm going to press it against the ground pad, and now it's sitting perfectly there. So now I'll wait until this chip cools down, and once it's cooled down, I will power on the power supply, and I'll go slowly upwards in voltage, and all the while checking the output of this chip and making sure that I get 12 volts and not something else. Let's see. So right now it's still a little bit hot. And I think so. This is kind of an issue that I've been having with factory assembly on this board because I'm using vias which go directly to the ground plane, and it seems that these vias are far too good at leading away the heat, so they kind of interfere with the soldering process, at least in some cases. So I suspect that it could have been also the same issue with this 5-volt regulator, which also has vias going through the pads into the ground plane. So the heat is actually very well led away from these pads. And the downside is that they don't melt properly during soldering, which, I mean, if they bake the boards properly, then it shouldn't be an issue. But I don't know exactly how they assemble it when it's a small number of boards. Maybe they actually assemble it in some other way, maybe some half manual way of assembly. I don't know. But it seems to be that at least based on what I can see, the components, these two components that have this, actually, I mean, this chip has been perfectly mounted. So, you know, it's probably just a theory that I have. but this is something that I haven't been using before, at least not in this way. But I decided to evaluate this way of heat sinking the chips, which could be causing an issue, but maybe not necessarily. Okay, now it's cold, so now I can connect the multimeter and check whether this is actually giving me 12 volts on the output. So let's see. This is not giving me 12 volts on the output. This is not actually working. So next I will, the only other component here which I think could be not connected properly is maybe the inductor. But before I do anything to the inductor, I will check what resistance I get between the pins that are connected to the inductor. So let's see. So I have R48 here, and this should be connected. I will actually check on D12 and R48. Let's check on between D12 and R48. So D12 is there and R48 is let's check where it is. Where is this component? There. This isn't really necessary to have that thick of a trace there, but that wouldn't cause any issues. So R48 is over there, and I'll just take the outside of this resistor and check with, let's see, I can check with D12 there. So this looks like it's not actually connected. So I'll just try this again. No, this is not actually connected. So I need to resolder this inductor. Try again. So anyway, I think that it's kind of it seems to be an issue with this manufacturing run, that pads that have a larger area and that have something that sinks the heat, they haven't been soldered properly. It's only 2 boards out of 6 have worked without any modifications besides the Zener diodes. The rest have had issues like this. I can actually remove the nozzle right now. I'll just get the nozzle off. Put it here so. I think I may have some trouble desoldering this inductor because it's going to take some heat to actually get this off. And I can't reach with a soldering iron there. It's too close to that fuse. So I'll have to just heat it up and then try to push it off. keep heating it on the other side with the 360-degree soldering iron, and hot air on this side. It kind of smells. It kind of seems like it's. I can hear it clicking, which doesn't feel very. Like it seems that it's kind of not. It's not doing very well, and the power is turned off, so there's nothing that that could be. Let's see. So it couldn't be the power that is destroying it, but it doesn't smell very well. It smells like a burnt component. So I wonder what happened to this inductor. I can't get it off at this point. So I need to try to desolder it. A bit more heat all around it. Maybe I can reach with my leaded solder and just put some solder down on the pad and then hope that it kind of will reflow. Let's see. Hold on. This could actually solder it on a little bit better. Okay. I can see that the solder is molten there on both sides. Okay, I'll leave it like this for now and let it cool. And while it's cooling, I could actually check the resistance again. And if I get something that's closer to 0, then I know that it's connected. Yep. So check this out. So now, when I check the same circuit from the D12 to R48, I get almost 0 ohm. So now the inductor is connected. But I don't know if the inductor is actually going to be working because it was kind of clicking from the heat. So it could be destroyed by the heat, but I don't know. We'll see. Just let it. Oh shit! Wait, there was actually a solder ball there. I need to remove this solder ball. This is not good. I don't want to have any solder balls anywhere. So the solder joint on this inductor wasn't actually perfect. It's really hot, and it takes a while for it to cool down. I'm going to check if it has cooled down now. I'm just going to reply to some email. Okay, it's cooled down now. It's still a bit hot, but it's not as hot as it was before. So now I'm going to connect the multimeter, and I'm going to try to increase the voltage and see if I can get 12 volts there. And if I get anything beyond like the 2 volts that I was getting before, then I'll switch to actually looking at the 5 volt regulator, because that's the one that's of interest for me on these boards. Let's see. I don't want to have the 5 volt regulator go above 5 volts. So this is actually not. This is not even like. I have it on 4 volts now. It's the same issue. The issue hasn't disappeared. So something else is screwed up on this board. Something else beyond the inductor. In terms of the fuse, I don't have any fuse on before this regulator. That fuse is going to be outside of the board. So the only fuse I have is past this regulator. So I should be getting 12 volts on this regulator. But right now I'm not getting any 12 volts on it. I'm going to try to debug this further, and we'll see if I can figure out what the problem is. So now, what I could do actually is I could check actually if I have any of these chips from the factory. So the factory delivered like a bunch of plastic bags with some leftover components. And if I have any chip, any TPS54360 there, then I could just try replacing this chip and see if that could be the issue. I wonder if I have any DRV chips as well. That would be nice. Nope. Like, one of the things I find quite annoying is that they sent a bunch of empty plastic bags, but I guess it'll be kind of time consuming for them to go over all of the bags and just and check if there's any components left in them, which is not really an issue for me. I could go over all the bags and throw out any bags that are completely empty. I'm glad though that they have sent the components. That's really a big plus. I would rather get the components than not get them. It's nice that I get all of the leftover components sent to me. So I'm not going to complain. Let's see. 14858. This I got a few of these, but I need to find TPS54360. TOV regulator, this is also an empty bag. So I'm going to throw it away. I'll check the rest of the. Let's see. A bunch of empty bags. Let's see, could this be? is this? Oh, this is 75 centi. This is, I think, is this actually? Oh, this is the EEPROM. Okay. Empty bag. Op-amp. TLV 2474. What is this? Empty bag. Yep. Actually, what I thought at first was a component name, 14585. That's actually some kind of number for this order. So I have to check the details that are scribbled on the bags to know which component it is. What is this? 2026. This could be. This is not a plastic bag. There's something that's left over here. What chip is this? Yeah, this is the USB, the power management chip used for switching the power. This one's an empty bag. Oh, 62147. Okay, this was the other regulator. It was empty, and this is. I think I'm pretty sure that there wouldn't be any components, any regulators left over. Because they only have, they only order slightly larger number of components for things that could actually be damaged, like EEPROMs, maybe, you know, if there is some, what is this? Oh, this is diodes. If there is some memory location in the EEPROM that's broken, which could actually happen quite easily from some ESD exposure. This one is empty. Oh, I think this one is actually TPS. TPS54360. Woohoo! I actually have one. Here's one. I actually have a regulator. So I'm gonna try to replace this regulator. Maybe it's going to work. Before I do that, though, I will just double check as many connections as possible, just to make sure that it's not something else. So let's see. I'm going to check D12 using the diode test, and I should get something like 200. So this is going to be diode voltage drop of somewhere around 200, I think. I would need to check the data sheet to know for sure. Yeah, so this is 200. Oh, I'm just going to bring up the camera. There, I have my camera. So this will be, this has a diode drop of 200, so this diode is okay. In the reverse order, it shouldn't be anything. Yeah, it's nothing. Let's see. So I could also, the capacitor, let's see, R48 and R49. I'm going to check R39, although I'm pretty sure that there is input voltage there. Yeah, that resistor is fine. And there is input voltage going to pin number 2. Let's double check that. So we got, no? Is that? is that for real? So pin number 2 is actually not connected. What? Maybe I'm doing something wrong here. Oh, actually, yeah. So this is connected through this diode, which let's see, which we cannot just test like that. So I'm gonna test this. This diode is fine, but then I have to test continuity from the cathode of this diode to pin number 2. Yeah, it seems to be fine. So there is power going into this chip. Yeah. And something else I'm going to check is actually let's see. Can I get some resistance on this coil? I wonder if that will work. While the coil is completely mounted on the, let's see, I get some reference value, maybe 0.3. What about this one? Like what? 0.3. Yeah, so that seems to be exactly the same as on the working board. Anything else I could rule out here? I could look at the compensation actually. Maybe it has to do with something with compensation, or the enable pin. The enable pin should actually be internally, like it's okay to leave the enable pin floating, but we don't want it to be shorted to anything. Let's change this to diode. Yeah. There's nothing wrong there. And pin number 4 should have a resistance of something like 137. Like, of course, testing like this is not optimal. I will not get any exact resistances. It's just going to be kind of like an estimate. Okay, this is R40 something. Maybe this is actually R40. It's like gives me 13. Yeah. So these values are going to fluctuate a lot because they're also a function of internal capacitors, and all the capacitors actually on the board. So when measuring like this, the resistance is going to either grow, like usually it will actually grow, because as capacitors charge up, their resistance increases, their resistance to DC voltage. So next I'm just going to look at this through the microscope and see if I can see anything that's obvious enough to be a possible problem. Let's have a look. So this is our TPS chip. This one is soldered on. This resistor looks kind of, this is R40. It looks kind of like it's not soldered properly. I'm going to try to resolder it. These ones are soldered okay. Yeah. Seems fine. All of this seems fine. The chip is slightly off center, but it shouldn't really matter. And this inductor is definitely, or this is actually the diode. This is the inductor here. The inductor is also mounted, and it looks like it's soldered. It looks like it's been like it started to melt, but it also looks like it cooled down very quickly, because the heat sinking is so good to the ground plane. This should probably be reheated. But I think the inductor is actually now connected. It wasn't connected before, but now it's connected. So I will just get the R40 properly soldered, and then and then I'll try removing the chip and actually replacing it with another one. Let's see. So this R40 is now in place. Let's check if we get anything out of this chip. Yeah, nothing. Something else that I could do also is just looking through the scope and just checking each pin. So I'm gonna open up my scope window here, and this should, let's see, there we go. I need to set the trigger on channel 1. Let's check pin number 1. So pin number 1 is going to be pin number 1 is actually going to be the bootstrapping pin. So I'm going to increase the voltage. So this is what we get. This looks like it's either like shorted somehow. Pin number 2, by the way, so this is 6 volts on the input. Pin number 3 is an enable pin, and that has 1 volt. Actually, no, this is actually 2 volts. Okay. I wonder if this, no, it will not increase. And this is pin number 4, which should be the external clocking pin. Pin number 9, ground. Pin number 9 is the ground pad, and pin number 7 is the ground. Pin number 8 is the switching pin, which is just a steady voltage. There is nothing coming out of this. So because the output is just a steady voltage, it's definitely not shorted anywhere, but there is something wrong with this chip. Let's see. What about so C30? Could it be something with C30? Oh, this is really weird. This chip is definitely not behaving as it should. I'm going to remove it and replace it with a new chip, just to rule out any possibility that this chip is actually broken. Yeah. And next I'll just take this chip that I got from the factory. This looks like it's unused. And I will just solder it on. Let's see. Okay, cool. And it's a good idea to actually use some, put some flux on this ground pad, because I want everything to reflow perfectly. And let's put this on. Okay. Turn on the I'm going to solder on the chip that I got from the factory. Okay. I'm just going to finish up with a little bit of sealing at the top side of the pins, making sure that everything is completely soldered. Okay. And now I'm going to wait until everything is cooled down. I kind of have my doubts about this being a broken regulator. I think it's more likely that it's something else, but it's still worth a try. Okay, so connect this one there and this one there. Let's increase the voltage. Yeah, this is pretty much giving the same result. This is not working. Now the input voltage is 10 volts. This is not switching at all. The other issue, which I think could be at fault, is the inductor. So this inductor could be broken. Like at this point, it could be anything. It could be an inductor, it could be the bootstrap capacitor, it could be something else. It could be even one of the resistors in the feedback circuit. I'm going to desolder the inductor, but before I do that, I'm going to just try to resolder C30. C30 is quite important. And I'm quite not liking the smell. The smell of burnt plastic. I assume it's probably the this green connector there, but it just doesn't smell good. It smells like a burnt component. I'm going to try getting this inductor off. Okay. Inductor is off. I don't think it's anything wrong with this inductor. It's such a sturdy inductor. Could it really be at fault here? kind of thinking maybe I should have put a slightly larger part here. I'm gonna check this for shorts once again. I don't think there is a short there, just in case. TP17. Yeah. No short there. Yeah. This is kind of what happens. It's like it's a 2 point. Yeah, it's just not working. So 2.5 volts. This is supposed to be 5 volts. As I go up in voltage, now I'm at 12 volts input. It's like voltage that fluctuates like that. One of the things that I forgot to check here actually is whether the ground pad is still connected to ground. Like maybe there was some short or something. I don't know. It would be good to check just to make sure. Okay. It's probably connected to ground. There's probably no problem with this ground pad. Yeah. Now that the chip is taken off, I could actually check some of the other pins here. So pin number 7 is also ground. It's connected. What about resistances? So let's see, we have pin number 8 should have resistance to ground. Like what the hell? Pin number 8. Pin number 8 is not supposed to be shorted to ground. Pin number 7 is supposed to be shorted to ground, but not pin number 8. There's 9.5K. So could this be something like C38 or C168? C38 is over there, and C168. Where's C168? Maybe one of these capacitors is shorted. But why was I getting... Okay. But why was I not getting a short from... Maybe I didn't measure it past the fuse. So this ground. Like when doing it like this, it doesn't show as short. So it's a short. It has some resistance. Or maybe this was just an effect of having some voltage in the capacitors. Or actually something being charged up here. I don't know. This one, R40. I really want to check R40. This one is supposed to be measured by this setting of the multimeter, but it's not. Like, what the hell is wrong with this resistor? Burned. It's definitely not giving any resistance. Okay. I'm gonna check if I've got some resistors from the factory with 137K resistance. We got something that looks like 147K, 147.7. I suppose we could try this. This is 805. No. This is not going to fit. Or maybe it was 603. 10K. 270R. .7K, a bit too small. Oh, I found it. This is 137K. Awesome. And I'm just gonna check whether this measures this 137K. Yeah, you can see this one measures fine. The other one didn't measure. So I'm gonna replace this. We'll see if this fixes the issue. I'm going to solder on the chip as well. what's the resistance now between spin and ground? 37. I'm surprised that the other resistor is actually broken. Okay. I'm gonna wait until this cools down a little bit. Still a bit hot. Okay. It's time to check if this regulator may be working. But I seriously doubt it's going to be working. Oh, look at that! It's actually working. Awesome. So let's have a look at the 5 volts output here, and just make sure that our 5 volt output doesn't go above 5 volts. Let's see, what is this? Okay. What is this? Okay, that's 4.97. Let's see here. So this is actually the this is the 5 volts. There we go. So 5 volts remains at 5 volts, which is great. Which means that we could probably up this up to 24 volts and then power on the board and see if everything is working. Let's put this to 24 volts. Okay, so I have 24 volts on the input now. 23.8. And now it's time to connect the console and programming cable and flash the firmware and see if we can blink the LED. So it's actually much more that's going to be happening in the firmware. It's just that I have the LED blink is kind of the sign that the firmware is actually running. Data and the clock. And the debugging interface. I'll plug in the link again, and I'm going to go to my firmware here. And in this console, we should see now all the boot messages. So let's flash the firmware. This is the first time I flash a firmware on this chip, and it's not actually working. Interesting. this wrong. I really have to check just to make sure that I have 3.3 volts. Let's see. I'm going to check the increase the voltage, and should I? Yeah, I have 3.3 volts on the CPU power. And I have 3.3 volts on the peripheral power. So those things are working. But then what I also need to check is whether I have 3.3 volts on the analog supply. And the analog supply goes here. So the way it works on STM32 is that if you don't have VDD-A, you will not be able to flash the chip. I need to make sure that VDD-A is actually working here. Let's see, that will be that pin. .3 volts. So this one is running. What could be the issue? Here is the issue. I got the cables slightly wrong. Let's see. Let's get all the cables right. So untangle them and let's get them all right. So we got the transmission reception here. And we have the clock and data here. Clock and data. Okay, time to try again. I'm going to plug in the ST-Link again and try this. And I think it's flashing. Yeah, this board is working. Alright, and we can see that we get correct DC calibration values here. So the current sensing is working, the motor, the power stage drivers are powered up, and let's reboot this and see what could be. Yeah, and we don't get any red messages. But I'm going to improve the code base and make sure that I do more tests during boot up in order to discover any possible faults with the hardware when the firmware is booting. But this board is fixed now. And the problem was that resistor. The problem was this 137K resistor that was actually broken on the factory assembled board for some reason. Maybe it was broken when it was on the tape, but for some reason this resistor was broken, and the regulator doesn't work if this resistor is not there. R40. So getting this resistor replaced with a working resistor actually fixed the problem. Alright, so I got 3 working boards, and I possibly could have had more if I didn't burn 2 of them when I had the shorts on the 5-volt regulator. But anyway, I got 3 boards that are working from factory, from the batch that I got factory assembled, and I'm gonna get the rest of them working as well. But before I do that, I will finish the review of my code base and I will implement more tests for the hardware so that I can have an easier time finding faults just by booting the firmware. So that's the subject for the next few videos. Thanks for watching, and bye.